I got a little bit obsessed with injection vulnerabilities over the last couple of years. I don't know what you've been doing, but so there's a bit of a problem with injection vulnerabilities. They have been around forever, and we haven't found a solution to them. We've got partial solutions, but mistakes are still made. That's why they're still on the OWASP top 10. I'm assuming most people know what an injection vulnerability is. This one is an SQL injection vulnerability, taking the user input and putting it straight into the SQL. The developer thinks this is going to happen, and then when the evil person comes along, they stick their own bit of SQL in here. So all great. First part of the solution, parameterized queries. Everyone knows how to use them, but it does rely on the developer doing it correctly. And if you think of junior developers coming along, you can't be sure that they're actually going to parameterize the queries. The next thing is database abstractions. They can help with you with this, but most of them have complexity in there, and it's easy to get them wrong. So if you're looking through the documentation, you have to know which parameters are safe and which ones aren't. And again, when you come back to your junior developers, they kind of make mistakes. I've built a website about injection vulnerabilities. There's loads of examples on there, but just taking Doctrine as an example, because that's probably one of the most that people are familiar with. It gets a little bit complicated, and this is just the first example that Doctrine uses for its query builder. Doctrine has a few different modes, but can you tell me with full honesty you know which ones are sensitive values or not? As in, could people make mistakes with this? So let's just take a very simple example of how Doctrine would work, the query builder side of it, if you were doing your basic select. This is how they'd expect you to work. You'd use the marker for identifier, and then you'll provide it separately. However, once a junior developer did this, because it's easier, you know, they could be modifying something, and now they've introduced an injection vulnerability. Now your database abstraction, which you thought was keeping you safe, has now just made a massive hole, and it's not exactly obvious that that's happened. So another two is Propel and Redbean. I'm kind of mixing the two because there's some similarities between them, but this is how they would often do it, is you'll have a two parameter part to this. The first part is for the database query, the SQL, and then the value from the user is kept separately. This is it working correctly. You're saying the author ID is ID. You can do things like this. Author ID is null, and that just doesn't need any user input. You can use functions. But now if you think of a scenario where you've got a blog where maybe they're listing all the long form articles, here's the query you might have started with by saying anything that has a word count of greater than 1,000. Now you're going to give the junior developer a little task to say, well, can we make it customizable? Because what some people might decide is long form varies. Now in your head, because you're a more senior developer, you know that it's supposed to be word count greater than, and then you provide the count separately. Junior developer could easily concatenate it into the first parameter. And it's that little difference there which makes you vulnerable to an injection vulnerability, which is a bit of a problem because Phantom comes along and makes this, and they start selecting information from your admin table. Great. It's the same actually with HTML. This is how Twig would work. You're giving it a template, and you basically provide the two values separately, and it will HTML encode it. If the junior developer did this, they've just provided what they think is HTML to the templating engine. Template engine has no idea. And again, you've got the same problem. In this case, I'm just passing some JavaScript from our evil attacker. Also, it's worth noting, in addition to this, templating engines have to be context aware, which is slightly going off the topic, because it doesn't know that a href is a sensitive value. It will HTML encode it, but it doesn't know it's part of a link. And thank you, Dave, for reminding me this. Okay. And command line injection, similar sort of thing. If you put user values in it, becomes a problem. Okay. Now, Mike Samuel in 2019 came up with this statement: distinguishing strings from a trusted developer from strings that may be attack and controlled. And this is the distinction which actually helps us solve this problem. If we just sort of categorize our variables into the two types, we can start making some progress. Christoph Kern had done some previous work. He also works at Google and has a couple of talks on this, Usenix Security 2015 and AppSec California 2016. The second one is a link there. And a load of Google engineers had written up a book about it, particularly page 266, talks about this technique, which has started with taint checking. Now, taint checking is fine, but there's a slight flaw to it, but we'll start with where it starts with. So that is a variable that's defined in the source code. It's untainted. Great, fantastic. Therefore, the variable is untainted. We can pass it through. If you have three parts, you have the untainted hi, then the name, and that. When they get combined together, HTML is now tainted, and the library could reject that. The flaw, well, actually, we'll explain first of all, with untainted things, if you pass them through a HTML encoding function in this case, that will consider it untainted. It has been escaped and therefore it's treated as safe. And that's the example output, and that's worked absolutely correctly. We're all happy with that. But it's not sure about the context, and it assumes that any escaping is good, which is not always useful. So we go back to our link example. We're using HTML encoding on the URL variable. It does escape the ampersand single, sort of, double quotes, less than sign and greater than sign. Now, theoretically, that's safe according to tainting, or taint checking. But if you put in a JavaScript :alert, you have a problem, another HTML injection vulnerability. This one's another one. Same principle, but it's SRC. Should be safe, right? But there's missing quote marks around it. So you can just say SRC equals /, that will be an invalid URL, and then on error, alert, and you've got yourself the attack. If you do put the single quotes on it, same theory, yes, everyone happy with this? Doesn't work. Well, actually it does now. Sorry, slight bragging rights here. Before PHP 8.1, single quotes weren't encoded by default, and that's something I managed to get changed. Yay! Because a lot of people didn't know that, including myself. Whoops. So where ID equals MySQL escape string, it's the same problem. If you don't put your quotes around it, you have a problem. And in this case, you'll notice that I have not actually put in any single double quotes in, just appended onto the end, and we've got another injection vulnerability. A lot of these escaping things, you'll notice that if you're using escaping, you'll be using hundreds, if not thousands of them through your code base. Can you be sure every single one of those is correct? No, I don't think so. So taint check is close, but escaping should be done by a library. So the escaping part should be done elsewhere by something that knows how to escape based on context. But we can still take that taint checking idea and just simplify it. And just simply say strings from a trusted developer. Ignore all escaping. We're not going to accept that. So we're going to say safe, and it's specifically safe in terms of injection vulnerabilities. We'll come back to that later. Developers. And then unsafe is just simply everything else. So here is our first example where we used parameterized queries. That is safe, unsafe, all good. If you had concatenated it into the two, that is now not a developer-defined string, because we've now taken user input, and now the library can reject it. If you had the twig example, this is all good. They're kept separate. HTML is a developer-defined string, all good. And again, user value, and that gets rejected because it's not a developer-defined string anymore. Same, yeah, a bit repetitive. Now, the bit that I'm going to focus on a little bit about why it's asterisk safe, that is technically safe from an injection vulnerability point of view. However, if Phantom was to set the path to just simply /, ignoring some slight modifications to the rm command in recent years, which stops this particular command from running, you now get the rm-rf. That's not an injection vulnerability, but it is a problem. Unfortunately, I can't stop that one. But yes, anyway. So whenever I'm presenting this idea, the first thing that people say is, well, what about the wherein clause? You know, you've got a variable number of parameters. And the answer, you know, as in they all do the IDs. But are you sure you've actually made sure that they are actually integers? You know, what happens if you forgot to do the interval thing, which has happened in WordPress once? Another way of doing it, continue to use parameters. Just put in a relevant number of question marks. In this case, I made a very simple in parameters. I'm using this particular style because it works with something I'm about to talk about in a bit. Another approach is variable field names, because you might want to do like an order by. You know, if you imagine you've got a table that you want to sort by different things, or the user wants to choose. Why not actually define your list of allowed fields rather than letting the user choose what they want to sort by, rather than sort of saying, I'm going to sort the admin table by password. I know it would be hashed, wouldn't it? Okay, so that's your list of array. It is a little bit complicated, but your database abstraction should be able to tidy this up a little bit. Because all it's doing is just simply finding the ID of what it should be sorted by and then just bringing it back. So these are developer-defined strings. That's a developer-defined string. They get concatenated together and all is good. Another approach is use the keys for the thing which the user defines, the values as the SQL, and then the SQL gets appended in. There is a little bit of repetition here because if you've got a default, you notice there. Okay, config values. I'm going to cheat, and I'm going to come back to that in a bit, because the library has to deal with that, and that's done later in the process. So how do we do this? We can do it with static analysis. SARM can do this today. Matthew Brown worked on that. You just do a simple install. If you're using SARM, you've got to use level 3 or stricter. Anything below it doesn't check this thing, so we are going to have to work a little bit more than average. But the only thing we're really doing is just saying that the parameter is a literal string. That's the only addition I made to this. Now, if you look at the bottom, I've got an example of how it should be used and an example of how it really should not be used, where I've concatenated it. And when I ran SARM on it, it rejected that second one because it's no longer a literal string, otherwise known as a developer design string. PHPStan also does it. Andre worked on that. And this one's a little bit more complicated. It's level 5 or stricter when it's only one type. If you're doing multiple types, like you're saying an integer or string, then it needs to be level 7. Yeah, it's exactly the same. You just say it's a literal string, and exactly the same works again if you're catenating it in. So that is how you define it. Going with the identifiers in SQL, you have your allowed list. This was the bit that I skipped earlier. The library would have to now deal with identifiers which aren't on a list. I can't imagine there's many cases where you need to do this, but people complain, and here is the solution. What I'd suggest is you make sure the SQL contains a placeholder or a named placeholder, and then the library goes ahead and escapes it as an identifier later. This means that it will always be escaped as an identifier, and it's always restricted as much as possible. Say most people never need to do this. So there is a small problem with static analysis. Not many people use it. So my intention and my obsession is to try and make it available to everyone. This means running at runtime rather than this. And this is perhaps a little bit optimistic as well, because if you look at the same thing, it's suggesting that 67% of developers use Laravel. Last time I checked, there's quite a lot more WordPress developers. So, you know, if we're going to solve this problem, we're going to need to, you know, push people towards static analysis, great, but also recognize that we're not going to get everyone there. So, making it part of the language. So, other languages have similar techniques that they can already use. In Go, I'm not going to go into it because we don't have enough time, but unexported string types, I've got these all listed on the website. Rust, procedural macros, C++, a constant evaluation. In Java, compile time constant, it's just another name for it. In Node, you can do a Google string constant, it's a Google library extension. In Node, template object. In JavaScript, we'll hopefully have is template object and trusted HTML from literal. Both of those are only accepting the literal strings. But PHP and the is literal RFC. Joe Watkins made the implementation, and Mate did the testing, the performance testing of it. Unfortunately, the RFC did fail, but for silly reasons, like people thinking, oh, I don't like it to be voted on so close to the deadline, which, I think that's fair. You're not rushing it. People thinking that it can be done in other ways, or, but then no one ever found a problem with this solution. They just had other ideas. So you're going to have another go at it. The idea is to make sure there's no dependencies, make it easy to use, no need to use static analysis, but actually it works well with it, because the whole point is to make this easy. And also work with existing code and libraries, because the problem is you don't want to sort of say, oh, there's this fantastic solution, but you're going to have to rewrite all your projects. That's not going to happen. And you can choose how to handle mistakes, because it's done at runtime. You can sort of do an if statement and choose how to do it. It avoids the need for developers to have to read all documentation and ultimately never making a mistake. How it would run, with a bit of backwards compatibility check, you'll just check to see if the function exists. Otherwise, it just runs that. And then I'm just going to call that private method to do it. The reason I've used the private method is because that's probably a little bit too strict, just throwing an exception. A more realistic library will probably have protection levels, because each project's going to take time to work on this. It's a bit of a mess, but ultimately, protection level 0 is saying, I don't care, let me have vulnerabilities. I'm explicitly going to unsafe, disable injection protection. The default is level 1, where you just do warnings, stick them in the log file, pester people, but ultimately don't stop the website. And when you get to level 2, then we're going to start throwing the exceptions again. And it allows you that flexibility. You can choose to log things and do all sorts of things. It also allows you to have a bypass on a per instance basis, rather than just simply disabling it for all things. And you can do that with a very simple value object. By just making this kind of value object, it still acts like a string, but you're explicitly saying this string is unsafe. And I will refactor it later. So that's how you'd use it. As in, you say new unsafe value, put it in. I don't know why you would do this, but let's assume that it's been done elsewhere. But it makes it very easy for me to find, because I'd look for anything that says unsafe on it, and I can sort of check it over. Now we're showing that example. How I would actually work it, you do your literal check on the SQL as it first comes in, and then you apply your identifiers later. In this case, I'm being very strict and saying that identifiers can only allow certain characters. You could do an escaping approach, which in MySQL is backtick gets replaced with a double backtick. Otherwise, everything else is allowed, and you make sure it's all quoted. Multiple ways of doing it. And that's over to you. The where example I had earlier in the talk, it's just one line. The order by, just one more line. Command line, have a function like this where you parameterize it. You can write this sort of function in, sorry, I'm going to skip over that. So you have the function there. This goes through the command, finding all the question marks, and it just simply escapes every single one of them and passes it through. It means make sure you've always parameterized every single value that goes in, and it gets run. Great. HTML, you could do something like this. This is the twig example from earlier. Just simply check the first bit as a developer-defined string or a literal, and that'll get rejected. I made one which is only 300 lines long, and that's context-aware escaping, which if you can do it in 300 lines at my level, I think you could have like a really impressive thing, with considering how large some of these libraries can get. This bit was just that protection level stuff at the beginning. Here are all the tags that I allow and the attributes and what is allowed in those attributes. So a href, that can only allow a URL, but image alt can now allow any text. Just do that. I'm using XML parsing because I think there's a certain quality in making sure your HTML validates to XML. I know that browsers don't care, but if you can do it, then great. Then I just do some very simple node walking, looking for the question marks, and then replace the HTML. And right at the very bottom is the thing. And that's how it works. You can also just prepare it, and you can run it multiple times. So it's quite a bit of flexibility in just 300 lines. Obviously, everyone can do their own thing. And then eventually, finally, in 10 years' time, actually start getting these functions starting to go, hang on a minute, because we don't know that the library's going to do it. Start off with accept everything, but warn if it's not a developer-defined string. However, You need to make a way for special cases because the libraries we trust. They've done all the work, their output's okay. So back to our stringable value object. Now, that's what we had earlier, but why don't we just call it DB trusted SQL? That means the library, when it's done all its magic, it creates one of these, and then would potentially in the PHP language say, this object is trusted for the SQL context, or maybe the MySQL context, because MySQL versus Postgres versus MS SQL and all that is a bit different. But once you said that object's accepted, I don't know if anyone's come across trusted types in JavaScript. I'm very much stealing that idea. And that's it. There should be a way to disable the check because not everyone's going to do it, and a way to enforce it. And again, back to Mike Samuel's thing of just simply that distinguishing. So yeah, cool.